Welcome everybody, I'm Adam. And in this problem, we're going to be solving the equation cosine of 2x minus cosine of x is equal to 0. Now, fundamentally what we want to do when we're solving trig equations is get all of our trig functions to one side and all constants to the other, which is pretty much what we're starting with. And on top of that, what we have is the left-hand side set equal to 0. And so looking into the future a little bit, we know from algebra that whenever we have an equation that's set equal to 0, we want to try to factor the left-hand side here and set each of those factors equal to 0 and solve from there. But before we get there, we have to simplify a little bit. So like we said, we want to factor. Now, one crucial thing to remember, right, is we have cosine of 2x minus cosine x. So we can't factor out a cosine, right? Keep in mind this 2x is on the inside of the cosine function, just like this x is on the inside of the cosine function. Right? So this is cosine of 2x on the inside, not 2 cosine x. Well, what can we do from there? Well, we know that we have, say, double angle identities. So we have three things to pick from. Which one should we do? Well, like we said, what we're going to try to do is eventually look at factoring the left-hand side. And taking a look at what we have, well, maybe starting at the bottom, if I were to substitute in for cosine 2x, 1 minus 2 sine squared x, well, then I'd have a sine squared and a cosine. Not really much factoring I could do there. Likewise, with the top, I'd have a cosine squared, but I'd still have a sine squared if we did sine squared minus cosine squared. Well, it looks like the middle, if we have 2 cosine squared minus 1, would give us a cosine squared term. With our cosine, looks like we'd end up with a quadratic in cosine, which we know how to factor quadratics from algebra. So it looks like our winner is going to be the middle one. Cosine 2x is equal to 2 cosine squared x minus 1. So we make our substitution. Cosine 2x is going to be equal to 2 cosine squared x minus 1. And that's minus our cosine x, and all equal to 0. Okay, so we'll just simplify it a little bit. Again, it looks like we have a quadratic on our left-hand side in terms of cosine. So we'll put our squared term first. So we have 2 cosine squared x, and then our first power term minus cosine x and minus the constant 1, and that's equal to 0. So there we go. We have the quadratic 2 cosine squared minus cosine minus 1. And then we want to factor this. All of that is set equal to 0. So starting at the front, well, what two factors will multiply together to give us a 2 cosine squared? Well, namely a 2 cosine times cosine. So 2 cosine times cosine, 2 cosine squared. And we look at our constant term, negative 1 on the end, look at factors of that, positive 1 and negative 1, and do our kind of guess and check method. But I think if we put positive 1 here and negative 1 there, and double check our multiplication, 2 cosine x times cosine gives us 2 cosine squared, minus 2 cosine plus cosine would give us a minus cosine, and positive 1 and negative 1, negative 1. So I think we're okay. So like we said, now we have the left-hand side factored, set equal to 0. So we're going to take each factor and set that equal to 0 and solve from there. So we have our first factor, 2 cosine x plus 1 is equal to 0. And we solve for cosine. We can subtract 1 and divide by 2. So we get cosine x is equal to negative 1/2. So before we solve, noting with our original equation, there was no domain restriction on the angle x. So what we're looking for is a general solution. We want a general solution. So starting between 0 and 2 pi, we know the values of x. They give us a cosine value of negative 1/2 are 2 pi over 3 and x equal 4 pi over 3. But again, for a general solution, we want all multiples of this, adding on the period of cosine, which is 2 pi. So adding on all multiples, of 2 pi, namely written as 2n pi. So 2 pi over 3 plus 2n pi, where n is some positive or negative whole number, and 4 pi over 3 plus 2n pi. So our first set of general solutions is right here. And now we're going to take a look at the second factor, cosine x minus 1 equals 0. And we solve that just to get cosine x equals positive 1. So again, the general solution, so between 0 and 2 pi, what values of x give us a positive 1? That is just, say, the value 0, but wanting the general solution, we take that and add all multiples of the period 2 pi or 2n pi. So we can write the solution like this, or just write it simply as all multiples of 2 pi. Which is the last of our solutions. So in solving the equation cosine of 2x minus cosine x equal to 0, we get the general solutions x equals 2 pi over 3 plus 2n pi, x equals 4 pi over 3 plus 2n pi, and x equals 2, just 2n pi. Thank you very much.